Alright, in this video I'll be finishing the lesson on radicals. And so let's go ahead and get started. So I'm looking for some number that you square to get x squared. So something squared equals x squared. Well, that would just be x. Well, here we're looking for some number that you square that gives you x to the sixth. What would that be? Well, it's got to be a power of x, and we have a power rule. Let me remind you what that is. If you have like x to the third raised to the fourth power, that would be x to the 12th power. That's what we call the power rule. So in this case, this would have to be x cubed. So x cubed is the number that you square to get x to the sixth. All right, so you can do the same thing for the next two. So here you're asking yourself, what number squared gives you x to the eighth? That would be x to the fourth. Notice 4 times 2 is the 8. Now what about this one here? You have something squared and you're taking the square root of that. Those are opposites, so you're just going to get x plus 6. The square basically undoes the square root. All right, let's look at E. So if you take the square root of 9, that would be 3. And if you take the square root of a to the 10th, that would be a to the 5th. So we get 3a to the 5th. So again, we're looking for something you squared that gives you 9a to the 10th. That would be 3a to the 5th. 3 squared is 9, and a to the 5th squared, you multiply the exponents, you get 10. So here you would get x to the 6th. What about this one here? This time it's a cube root. We're looking for something you cube that gives you x to the 9th. Well, it's got to be a power of x. Well, 3 times 3 is 9, so it must be x cubed. What we're really saying is if you multiply 3x cubes, you get x to the 9th. Well, this is a total of 9x's multiplied, so that's correct. So here we're looking for some number that you take to the 4th power to get x to the 12th. And notice that would be x cubed. There's actually a nice little shortcut. You could do 12 divide 4 and you get the 3. 9 divide 3 here, you get the 3. Remember, this is a 2. 12 divide 2, you get the 6. And so that's a nice little trick you can use. Just have to be careful with the numbers. All right, now there's something I haven't discussed with you we need to discuss. The problem is if I had the square root of 3 squared, that would be 3. Because 3 squared is 9, and the square root of 9 is 3. But isn't it also true that negative 3 squared, the square root of that would also be 3? Because negative 3 squared is 9, because negative 3 times negative 3 is 9, and the square root of 9 is 3. So notice if x were 3, I'd have x here and here. But if x were a negative number, then our signs would be opposite here. And so if this is an x, square root of x squared, it could either be the same as this value here, or they could have opposite signs like you do here. So for that reason, we have to say the absolute value of x. So the same thing would happen here. This would be the absolute value of x cubed. And now the problem is it's not an issue here because x to the fourth, see, the thing is when you take the square root of a number, actually I think the way I said it before was the best. It's possible that if our x is a negative number, that this value and this value have opposite signs. And so for that reason, we have to use the absolute value so that they have the same sign. They'll both be positive. I guess another way to say it is, we know the square root of a number is always positive. And so if x were a negative number here, if we don't make this absolute value of x, we would get a negative number. But because we have an even power here, that's not an issue. So here, if x is a negative number, or a number such that x plus 6 is negative, then we'd have the square root of a number equals a negative number. And so we got to do the same thing here. We'll have to do it here because this is to the 5th power. But notice here we're okay because anytime you have x to an even power, it's going to always be positive. So there's no issue here. It turns out with odd roots, we don't have an issue because you can take the cube root of a positive, like cube root of 27 would be 3. Cube root of negative 27 would be negative 3 because negative 3 to the 3rd power is negative 27. So we don't have this issue with odd roots like the cube root, but we do have to watch out when we have an even root. So in this case, we would have to make this the absolute value of x to the 3rd power. Because again, x could be a negative number, and if that's the case, x to the 3rd power without the absolute value would be a negative number. But we know that a square root or any even root, you cannot get a negative answer because there's no 4th power where you're going to get a negative number. And so the absolute value here is needed so that if x is a negative number, then x cubed, it has to be okay. It has to be positive. By putting the absolute value in there, you make it positive. All right. I just want to point out this issue where this x value could be negative or positive is something we only have to think about in this first chapter, or in this first section, 6.1. Later on, we'll just assume that our variables are positive, and we won't have to worry about writing them this way. But the main thing is, if you get an odd power of x as an answer, you're going to have to put absolute value around it. Same thing here. We had, well, we just got x plus 6 to the 1st power, so we needed the absolute value there. But when we get an answer like x to the 6th or x to the 4th, that's always a positive number, so we don't have to worry about it in those cases. Okay, so in general, the square root of a squared is equal to a, the absolute value of a. With cube roots, we don't have to worry about it. The cube root of a to the third is a. So if we have an even root, or let's see, if our root is odd, I should say, the nth root of a to the n is a. And if we have an even root, then we have to use the absolute value. All right, let's move on to number 13. So you may want to go ahead and try these and see which ones you can do, and then we'll go ahead and watch the video and see how you did. So here you're looking for something that you cube to get negative 8x to the third. Well, negative 2 to the third power is the negative 8. And of course, x to the third power gives you x cubed. So this is just negative 2x. This is the answer, because when you cube that, you get negative 8x cubed. The easiest way to do this one is write it as the cube root of 125 over the cube root of 64. And hopefully you wrote down the cubes earlier, or you might want to write them out if you don't already have them written out. Cube root of 125 is 5, since 5 to the third power is 125. And the cube root of 64 is 4, since 4 cubed is 64. So this is 5/4. Here we're looking for a number to the fourth power that gives you 81. We discussed that one earlier. It's 3. You can verify that 3 to the fourth power is 81. So what if you're looking for something to the fourth power that gives you negative 81? Well, we've talked about this when we had it squared. When we square, we can never get a negative. Because squaring like a negative 3, you'd have negative 3 times negative 3. That'd be positive. If you multiply 4 negatives, you can never be negative here. So maybe you thought it was negative 3. If you multiply 4 negatives, negative 3s, this is going to be a positive 9, this is going to be a positive 9. You're going to get 81, not negative 81. And so this is just like what we had with square roots. It's not a real number. Here we're looking for something you take to the fifth power to get negative 1. Well, it's got to be 1 or negative 1. That would be negative 1. Here you're looking for something to the seventh power that gives you x to the seventh. Well, that would be x. Now, since this is an odd root, it's okay to have this be x, because whether x is positive or negative is not an issue with odd roots. But here, you're looking for something to the eighth power that gives you x to the eighth. That would just be x. But again, if x were a negative number, then we'd be taking an even root and getting a negative answer. Like square root, we said, of a number cannot be negative. It's the same with any even root. And so here's where we need that absolute value. Here we're looking for something to the fourth power that gives you x minus 2 to the fourth power. That's just x minus 2. Again, since it's an even root, we're going to need absolute value around the x minus 2. Last one, we've got the fifth root of x minus 2 to the fifth power. So we're looking for something to the fifth power, since we're dealing with the fifth root, that's equal to x minus 2 to the fifth power. Well, that's just x minus 2. Do I need absolute value? No, because this is an odd root, not an even root. All right, so hopefully you're getting the hang of that with the little absolute value thing. After this section, we won't have to worry about that anymore. We'll just assume that our radicand is always positive. All right, so we're going to go ahead and stop right there, and that's it for the lesson on radical numbers, or radical expressions.